Yes, good day to you, students. Don't mind me. We have finished circle geometry, but I saw this interesting question, or Wahe question, and I felt it would be so sweet to discuss. So there is a need for me to discuss with you. I wanted to be doing it alone, enjoying it. I was going through it, and I thought, why would I do this alone? Like, why would I enjoy this interesting question alone? I can as well enjoy it with you. So that's why I had to bring it up so that we can see together and enjoy it. It's a wire question. Look at this. Obviously, when you see a question like this, trust me, it is nothing less than 12 marks because it's a theory question. Nothing less than 12 marks. As a matter of fact, questions like this do not come with another question that they can share. It's just directly 12 marks. Let's just enjoy this 12 marks out of 100 marks directly. Let's just see how 12 marks goes. Now, look at it. In the diagram below, ASRBTB represent a piece of string over a pulley of radius 10 centimeter. Then in a vertical plane, O is the center of the pulley and AMB is the horizontal straight line touching the pulley at M. Angle SAB is 90, SAB 90 degree. Angle TBA is 60 degrees. Then we are calculating the obtuse angle OSOT. That means obtuse angle SOT. That means this angle. This is a reflex angle. Then this is the obtuse angle SOT. Then we are solving for, let me call this one theta. Then arc SRT. We have this arc as well. Then we are solving for BT. That is BT. That is this length. Then the nearest is the length of the string. Then we are calculating this one, the length of the string. Interesting. Let me explain to you what I feel here before we continue. Then to solve for obtuse angle SOT, this angle, we are looking at this angle. I am sure if this one is 10 centimeter, this one also is 10 centimeter. If I link this one to this side, don't forget this is my radius and tangent. Definitely this will be 90 degrees. If this one is 90 degrees, obviously this will be 90 degrees. If this will be 90 degrees, perfect. Then this also will be 90 degrees. Are we together? So if this is 90 degrees and these two will be 90 degrees, why? You know 90 degrees. Now we have discussed radius with a tangent, the relationship between radius and tangent. So that's why I said this one is 90 degrees, this one is 90 degrees. So far this one is 60 degrees. Then quadrilateral, I'm not saying cyclic quadrilateral this time. I'm saying quadrilateral, normal quadrilateral, that is 4 sides and 4 angles can give us this. So once we get this, then we add it to this, subtract it from 360, we have this. Problem 1 solved. Enjoy it. So let's see now. Let me write this out because of our mark. Let me say, okay, let me demarcate this so that we can have enough space. Let me say SOM is equal to AMO, which is equal to BTO, which is equal to 90 degrees. Radii and tangent, or you call it theorem 7. So, or theorem 6, that's theorem 6. So if this one is what we have, this one, I just want to be brief about it so that you can enjoy the rest of your day. So let me see. So from here we have 90. Therefore 90, that means this 90 let's say BMO plus BTO, these angles plus I have this one BTO, and I have MBT, this one plus this angle, that is MOT, which will be equal to 360, angle at a point. So from here we have 90 plus 90 plus that's 90 plus 90 plus 60 plus this one plus MOT. Now which is equal to 360 degrees. 90 plus 90, that is 180. 180 plus 60, that is 240. So we have MOT is equal to 360 minus 240. Is it 240, 90, 180, 180, 240, 240. So if you have 240, though my MOT will be equal to 0, that is 120. Is that 120? Yes, 120 degrees. So this one is 120 degrees. If this one is 120 degrees and this one is 90, therefore, SOT that we are looking for, that is reflect SOT, will be equal to 360. Oh, sorry, this is not what the point. This one is quadrilateral. This is a quadrilateral. Now we are using angle at the point now. That is minus 120 minus 90 degrees. So we have 360 minus this one plus this. So we have this one plus this. We have 210. So we have 210. So we have 150 here. Let me write it here. We have, so our SOT is equal to 150 degrees. That's all. That is that about SOT. So once we have SOT fixed out, so we have SOT to be 150. So we can go for, this one is cleared. We can go for our SRT. That is SRT. That is arc. And the length of an arc. The formula for the length of an arc, that is arc SRT. That means this arc. Definitely length of an arc, circumference, length of an arc is theta over 360. That means this theta, take it away from 2 pi r. 2 pi r, that is the circumference of a circle, because we are taking a degree from the entire 360. Don't forget the circumference of a circle is 360 over 360. That is the entire circle times 2 pi r, and 360 over 360 is 1. So 1 times 2 pi r is 2 pi r. So naturally, the circumference of a circle is 2 pi r. That's why we go through 2 pi r. But one here we are taking a particular degree from it. So it's going to be 150 over 360 multiplied by the circumference of the circle, which is 2 pi r. That's how I got my formula. So from here I have 150 over 360 times 2 times 22 over 7 times 10. So I will have, from calculation, I will have 26.19 centimeter. So this is what I have here. So this one is 26.19 centimeter. That is that. So to get the second one, that is the BT. That is BT now. That is this BT. Let's see how we get our BT. Our BT. Look up. Look up. This is 90 degrees. Don't forget our theorem 7 discusses something like this. Once we have tangents meeting at the outside the circle, we have this one. So this one will be equal to this one. That is 30, 30. So once we have 30 here and 30 here, this one is 10. We can use 30 and 10 to get our this, which is going to be equal to, this is going to be our hypotenuse now. We have opposite against adjacent. That is tangent. So let me redraw so that mark we won't lose any mark. So we have 30 degrees here. I have 10 here. Then I have my T here and B here. We are looking for this one. That is TB. So from here I have tangent. Tan 30 will be equal to 10 over x. So my x is going to be 10. Let me find somewhere to write this. So my x is going to be 10 over tan 30, which is going to be, I'm sure it's going to be 17.32 centimeters. So we have this. So once we have this one to be 17.32 centimeters, then we can go for the third question, which is the length of the string. That means the length of the string from A to S. From A to S, 10. Obviously 10. This is 10. This is going to be 10. Then plus this one. Then plus this one. That's all. So our B will now be 10 plus 26.19 plus 17 plus, let me write my plus here, plus 17.32. So from here we have 17 plus 26, that is going to be 43. 43 plus 10, that is 53. So 53 here, let's say this is 0.5. Let's say 0.5 centimeters. Then we are good. So from here we have this one given, this one given. So trust me, there is no way you will have your 12 marks completely without stress here. There's no way you will not have your 12 marks. This is actually interesting. So I just thought I could quickly go through this. Please check this out. Let me quickly explain again so that you understand better. Oh, I didn't write my reason here. My reason here is angle at the point. Angle at a point. Let us not forget. So I got my 120 degrees here because of my 1990 and 60 degrees that is here. So this point plus this one plus this one plus this one will be equal to 360. That is quadrilateral. So from there, we have this one to be 120. So angle at the point here will give us 90 plus 120 minus 360, which is 150. It is that 150 that we used here because we were asked to find SRT, the arc of and this arc is more like the 150 degree out of the 360 degrees. So that's why we have 150 degrees out of the 360 degree and your 2 pi r. So we have this one. Then to get BT, I noticed that this one is 90 degrees. And once I have 90 degrees, SOHCAHTOA will always work. So I use SOHCAHTOA here. Fortunately for us, we were treating circle geometry alongside with trigonometry. So if you don't know trigonometry very well, maybe you have been so particular or consistent about your circle geometry, please go through your trigonometry. You understand what we did here? That is this one against this one. That is SOHCAHTOA. That is this your opposite against your adjacent. Why this one is hypotenuse? I got to know this hypotenuse because this is 90 degree and the length that is facing the 90 degree is always your hypotenuse. Some people call it the longest line, but to me, I don't have measurement to measure it. Now it doesn't look like I have to know the longest. Let me just get my 90 degree. So once I know my 90 degree, I will definitely know my hypotenuse. And to the last question here, that is the correct to the nearest, the length of this string, the length of that string, that is string AS, then SRT, then TB. So we have 10 plus 26.19 plus 17.32. That is the addition that gave us that mark, that point. I hope you have enjoyed this work. If I have any other question that I actually found, I will definitely communicate it to you. Please check this again, play it over and over and over and over, and have your 12 marks.